Good morning, guys. Just a minute. Yeah, good morning, Sahu, Sunita. Okay, we'll start job first. So, what is this chopper means here? That is DC to DC converter. Or a DC again is converting to DC. मतलब magnitude is changing. Whereas in AC to DC converter, AC to DC, complete alternating current is being changed into, you can say, complete DC. मतलब ज़्यादा pulses. When you get more and more pulses, you'll have that more towards the DC, right? So let us see now. In chopper is one of the examples or application for this DC to DC converter. All your battery operated vehicles also works on this DC to DC converters. Let me see how this is going here. Simple. Why not? And this is load here. A load consisting of combinations. Inductor should be there definitely. RL. So what is happening here now? VS is continuously giving DC supply. This is DC. First time you are using DC supply. You want to get output voltage also DC. When you close the switch here now, on period, turn on period. Let me show you now. This is VS. Complete DC. So when you turn on this switch, so during on period or 0 to turn on time, then what will happen? ये वाला switch है ना, close कर दिया. Switch is nothing but some SCR or some device. You are making that speed is very much high. Switching frequencies are very high. Vs and this is V0. So V0 equal to Vs. Your V0 is, for example, you are saying this is, say this is 100 volts, just an example I'm giving. So you get this is 100 volts, just an example. So V0 equal to Vs. Turn on period था, ये वाला turn on. मान लो आपने को दिया 100 तक आ गया. इसके बाद what I have done is turn on total time period. Turn on to total time period or during turn off. So what I am doing here, switch को open कर दिया. Then Vs, ये वाला open है ना? What is V0? V0 equal to 0. So the simple, this is V0 0. Whatever the period you have turn off, again turn on कर दिया. This is on period. This is total time period. So this is T on कर दिया. This is T off. Total T is here. T on for T. This is the time period, I would say. So this is continuously on off कर दिया तो average voltage कितना आएगा? Total V0. So average voltage which is equal to turn on period. Average लेना चाहिए. Only on period में इसका voltage है, off period में नहीं है. Into PS. So this is T on by total T. Vs is your V0. So this T on by, this is called as duty cycle, represented with alpha, not firing angle, you can just something represented. So time period, or this can be, sometimes we call chopping period. So V0 becomes here now alpha Vs. So by controlling the chopping duty cycle alpha, we can do this one. Another thing is in terms of frequency, F equal to 1 by T. This is chopping frequency. We call कितना टाइम से मतलब कितना स्पीड से आप ऑन एंड ऑफ कर रहे हैं, इसको ऑन एंड ऑफ कर रहे हैं. That is a chopping frequency. Then V0 can be replaced here now. Look at this. This is one expression. So from 1, V0 is replaced 1 by time period is F T on and Vs. This way you can also define V naught equal to Ft on Vs. Copy. So if it is right, if load is RL load, two scenarios, इसमें क्या दो चीज आता है, तो R load and RLE load. R load में क्या होगा, R load में जब आपने ओपन किया उस समय आपको करंट भी डिस्कंटिन्यूस होगा, दैट इज I naught का करंट इज ओनली फॉर द T on period. For example, so I'm talking about this only. If load is R, then what is the output waveform? Just I'm writing same, circuit is same. Only thing is I'm adding a freewheeling diode. Load है, इसका value V0. Switch is closed here now, plus Vs. ठीक है? If load is R, V0 is, समझ में अगर close कर दिया तो anyway freewheeling diode is off. Only that period is on and off, and again it gets on and off. It's going on like this. Turn on, turn off. So I naught, what will happen I naught during on period? During on period, what will happen? ये वाला VSI, you can draw at the same phasor diagram itself. This is R. Load is R means V naught by R, which is equal to I naught. So I naught का भी same time I naught 0 हो जाएगा at turn on period के बाद. So then off, then on. I can control turn on, turn off also. T on, T off, of course total T. So you can see here now current is I is discontinuous. Current is discontinuous. If load is RL, load RLE also, no problem. RL भी हो सकता है, RLE भी हो सकता है. RL, inductive load है. हाईली इंडक्टिव लोड, आपको बता दिया क्या होगा हाईली इंडक्टिव लोड हुआ तो V नॉट है. सो दिस इज RLE लोड में देख लो. There is no problem in the voltage. I hope you understand this point. Need not explain. So turn on period में on है. जब ये वाला switch को off कर दिया, I'll explain that. During turn on, this is turn off में what is happening here? Turn off if RL load is there. So this is RL load. This is RL. So what will happen? Freewheeling diode है ना? पहले इधर प्लस माइनस, तो अभी प्लस होगा, ये वाला माइनस होगा. तो आपका फ्रीव्हीलिंग डायोड है ना, नीचे प्लस आए माइनस आए, तो फ्रीव्हीलिंग डायोड starts conducting. This is empty. So what will happen? The current starts flowing in the same direction. There is no change in the I0 direction. Current starts flowing in the same direction. But V0 is 0. There is no change in the V0. V0 तो फ्रीव्हीलिंग डायोड रखा, फिर भी V0 और टर्न ऑफ पीरियड 0 है. Again on, again on. This is on, off period, on period. So V0 is same, but only change will happen I0. मैंने बता लिया. टर्न ऑन, टर्न ऑफ पीरियड में क्या होगा? इंडक्टर हो गया ना, इंडक्टर I have kept RL low, so the current is kind of not discontinuous, so current increases gradually. Maybe if we start from 0, so it increases and it decreases here, okay, and then it increases because it's a current, right? RL load, slowly current decreases. During off period, inductor releases the energy to the load, so current decreases and then increases. This is how it will be. So current is, you can see here now, current is continuous with high L load, inductor load. Just copy this. I just copy this, just message one thing. Okay. So basically we'll keep RL load because our loads are kind of RL kind of thing. So for example, your DC motor has some inductance also, DC motor has some back EMF also. So RE and RLE kind of thing. And you might be wondering how these switches are kind of on and off. That we'll discuss a bit later, don't worry. So let me see here now. Abhideka harmonics, we are interested in the output side. We are interested in the output side voltage. So let me discuss about इसका Fourier series. Output voltage का Fourier series देखना चाहिए. Let me do that. So Fourier series. Fourier analysis of output voltage. This is the one V0 during on period and off, on and off, turn on, turn off. If you do the Fourier series for this, so V0 it has harmonics definitely. It's a non-sinusoidal waveform. It has harmonics. This is 2Vs by n pi sine n pi alpha. These are important again. All Fourier series analysis are important. 2Vs by n pi. And where alpha is, I know this, where alpha is V0 by Vs or V0 equal to alpha Vs. Alpha will be given to you. I would say, duty cycle मैंने बता दिया. So V0 equal to alpha Vs. And alpha is, of course, turn on by T. What is theta naught by theta n, by the way? It's a mathematical expression. Say mathematically हमको ये value मिला. So this is tan inverse of this is the one. So you can see maximum value when you are obtaining maximum value of nth harmonic occurs. इसका value maximum आना चाहिए. So maximum value, this is important. Maximum value of nth harmonic. Rather I would say Vn. This is nth harmonic occurs yet harmonic value maximum आएगा जब ये वाला maximum है. Sin n pi alpha equal to, how much is that? Sin n pi alpha 1. So n pi alpha कितना होना चाहिए? This has to be pi by 2, 90. So n pi alpha, pi get cancels out, alpha equal to 1 by 2 pi. This is the 1 point alpha. The duty cycle is alpha equal 1 by 2 pi. 2 pi equal alpha equal to 1 by 2n. N pi alpha pi by 2n, pi get cancelled, so alpha equal to 1 by 2n. And another point here now, yeah, even this 2vs pi n, if you want you can substitute that also. Anyway, in problems you can do that value. Nth harmonic current. I want to calculate nth harmonic current also. So how do we define here now? In, which is equal to Vn by Zn, of course, total when it is conducting voltage, supply voltage is equal to load voltage, definitely. So now Zn, I said Rn here, I said RL load, right? RL load में ही होगा, R load में. When we're talking about continuous current, you consider the RL load. Then it becomes R square plus XL square, R square plus L omega. L omega is 2 pi F. Harmonic increase हो गया, तो इसका N भी increase हो गया, L omega N whole square. Okay. So I know the Vn. Vn can be calculated. RMS value you can take it anyway. And then Zn can be calculated. You can calculate the current also and the harmonic current. There are few definitions of this one. Meaning average current, सब कुछ देखना चाहिए. So how to find that average current, average voltage, RMS voltage? We got the output voltage. For that we need to do some analysis. So let me do that here now. RMS output voltage. What is RMS output voltage here? इसका average voltage हमको पता चला. What is average voltage? V naught, I know it. V naught, which is equal to T on by T, which is Vs. This one is a average output voltage. And RMS output voltage. V naught R, average output voltage. V naught R here now. Same thing. 1 by under root here now. T on by T, Vs square. This becomes T on upon T into Vs. T on T kitna hoga? That is alpha. So this is what the RMS output voltage. Just RMS will definition likha maine. Output voltage, average output voltage, and average or RMS output voltage lekha. Right? Please copy this one. We'll move on. Then we'll see what will happen or what are the types of the choppers we have. Let me discuss that. Chopper is definitely DC to DC. DC input magnitude and output voltage को change करे. Input voltage मान लो 100 volts है. I can obtain 50 volts, 70 volts, 60 volts in the output. That is what DC to DC. Magnitude change कर रहा by using the switches. This is important. As I mentioned here now, Fourier series is important. This is Vn, right? Harmonic content. And if you write the total value, what is output voltage will be the DC value will be the V naught plus I can say sigma n equal to 1 to infinity Vn. So AC component का value इधर है. This is AC component value. क्योंकि DC by ना इसमें DC का value this is A naught. Fourier series कैसे लिखेगा हमने a naught plus sigma, right, n to infinity and cn, right? So that a naught is a DC value. When the waveform is symmetrical, ये वाला DC value will become 0. a naught becomes 0. हमने देखा अभी तक. लेकिन इधर a 0 नहीं होगा, p naught 0 नहीं होगा, ये वाला constant value. ठीक है? But we have to find the other harmonic content also here. Please copy that. We'll move on. So we have seen the step up chopper, step down chopper. Whatever we have discussed is step down chopper. मतलब VS 100 volts है तो आपको 50 मिलेगा. So this is what, whenever V naught which is equal to alpha VS, this is your step down chopper, where your V naught is less than VS and alpha in this case, of course, alpha is always T on by T, right? Alpha is less than 1 only. V naught is less than VS. Step down chopper we have discussed. If you look at the step up, what should happen here now? V naught is kind of greater than VS. ये कैसे होगा? Let us see here now. Step up chopper. Output voltage ज़्यादा होना चाहिए. So let me draw the network here for this. There is a voltage source. This is a critical key point. ये वाला chopper है. And this is V naught. Diode, inductor. Of course, you can show this as like a chopper switch. Whenever there is switch, ये कैसे on and off होगा बाद में देखेंगे. Chopper circuit is CH मान लो. VS. What is happening in the step up chopper during on period? Chopper को on कर दिया तो क्या होगा? So I hope I can draw the VS. VS is a steady value. क्योंकि supply है. When chopper is on, CH is on, then what will happen here? V naught, देखो T on period में, so then inductor is kind of energizing. इसको chopper को on कर दिया मैंने. When this gets short circuited, no current will flow here now. इसमें तो current नहीं आएगा. So then it gets open here now, and आपका load इधर है. So V naught value, which is equal to 0. Chopper on कर दे, energizing. Inductor is getting, L is charging up. So inductor takes energy in this period. So then B naught क्या होगा? Based on this one, ये short circuit हो गया ना, ये B naught 0 है entire during on period के लिए. During off, what will happen during off? I'm just drawing here now. Otherwise this one. During off, इसको open करना है. So chopper को open कर दिया तो क्या होगा? Look at the beauty of this. I have opened it, and the inductor is plus sign. Inductor diode is on. V naught. So Vs previously, look at here now. It was charging up here in this case. So energy is here now plus minus, matlab both the energies. Now it started releasing, right? So what it becomes here now? This become when it start releasing, ये वाला प्लस होगा, ये वाला माइनस होगा, क्योंकि एनर्जी रिलीज कर रहे हैं लोड को. VSI इंडक्टर इधर है, तो V नॉट क्या होगा अभी? ड्यूरिंग ऑफ पीरियड KVL अप्लाई करो. KVL, if you apply the KVL, V naught equal to this voltage plus this voltage. So V naught, which is equal to Vs plus LdI by dt. So very high voltage here now. मतलब inductor जो भी voltage आया, that get added to this. मान लो this is off period. Again on period. Again off period. Same thing. More voltage will come. See, for example, this is 100 volts. We don't know. This might be 300 volts or so. Just an example there. If this is 100 Vs during off period, maybe we might be having 300 in this case. Turn on, turn off, turn on, turn off. Total time is T here now. So see the current here now. How the current is changing. Whenever I say current, and you can see the current of the load only, I naught. So then, let me draw this please. Tell me now during on period, what is I naught here? If you understand this, you'll tell the answer. On period में, this is I naught. I naught का करंट क्या होगा? ऑन कर दिया मैंने चॉपर को, ठीक है, इसका करंट क्या होगा? What will happen to this current? Excellent guys. That is 0 because it's open. No current is going here now. बाद में देखेंगे इसको कंटिन्यूस कैसे करना. हमारा चीज क्या होना चाहिए? हम तो करंट कंटिन्यूस ही डालना चाहिए, क्योंकि मैंने बता दिया ऑलरेडी टॉर्क इज प्रोपोर्शनल टू 5Ia. तो ये वाला लोड मतलब लोड इज ऑलवेज a machine, a motor, a DC motor. If it is a output is DC, it's a DC motor. So motor rotate करने के लिए टॉर्क चाहिए, टॉर्क के लिए करंट चाहिए. अगर करंट नहीं तो टॉर्क नहीं है, मतलब पुश नहीं है, उसको पुश करना है मोटर आगे जाने के लिए. अगर ऑन एंड ऑफ कर रहे मतलब करंट को बंद कर रहे, करंट को चालू कर रहे, करंट दे रहे, तो इसको क्या होगा? इंटरमिटेंटली जाएगा, मतलब रोकेगा, थोड़ा पीछे आगे जाएगा. So something like intermittently kind of going on and off, on and off, on and off. That is not allowed, and motor has to run very smoothly. तो continuous current होना चाहिए. इसलिए always we strive to make the output current is continuous. ठीक है? Fine then. इधर 0 हो गया. Turn off period में देखो, I not initially very high current, क्योंकि energy in the inductor is kind of more voltage is more. Then what happens after that? As the energy is taken by this load, then current starts decreasing here now. So initially current is say I1, and now this current is decreasing here now because energy decreases in the inductor of Li square. Maybe here now maximum I1 and maybe you can say this is I1 initial current. And then again decrease on period में no current. This is turn on, turn off, no current. Again the same thing. During turn on chopper में inductor में energy आ रही. Inductor is taking the energy. Inductor is a kind of current source. So we have a more current in the beginning. And as the inductor releases the energy, terminals reverse हो गया देखा. As the inductor releases the energy, so this magnitude of current decreases. Half Li square is the energy. That way it is going on. How to obtain the average voltage? One thing is average voltage कैसा आएगा? You can take this one, which is given as T off by T on, but T off we cannot make T off. We always should do in terms of T ons or alpha. So let me find the average value for this one. Okay. So let me find what is average value. Average output voltage V0, which is equal to, okay, you can consider this one T off periodically, no issues. T off by T into Vs. Okay. Sorry, I disconnected somehow. Can you hear me now, guys? Are you there?
Yes, sir.
Yes, sir. Clear and loud.
Fine. So now what I was saying is, yeah, I'll redraw it, don't worry. Step up I'm talking about. So we got this one output voltage V0 is during on period may there is no voltage here now T on. During off period I have a voltage, and during on there is no voltage. Off I have a voltage. This is what we have obtained. And ये वाला time period है. This is total time period. So what is average value? Average output voltage is V0. So V0, which is equal to on period का only turn off distance है, turn off इधर से इधर है turn off time upon total time t into Vs, क्योंकि magnitude Vs है ना. So I would say here now T off कैसे लिख सकते हैं? I know this. T on plus T off is total T. So T off is T minus T on by T Vs. So then anything wrong here? This one V0 equal to T off by T. Okay. One thing, this can be done in a different fashion. I'll do it in energies. I'll come back to this expression. Let me do it in a kind of energies here now. I'll tell you where the mistake is. If we draw the current in inductor, I want to only take the current in inductor here now. Current in inductor, for example, IT1 or IL1, rather I can say here now. This is the network, right? This is the network, and inductor I have, and chopper is here now. This is where the chopper is there, and this is where load. Only IL1, for example, this is IL1. What is happening IL1? See, please understand carefully. During on period, inductor current is kind of increasing. IL1 or IS1, both are same. Current is kind of increasing because the inductor is kind of taking the energy. And then in this off period, what is happening here now? Current is kind of decreasing because energy is being released. Again, it's kind of increasing. This is what happening. Say, for example, मान लो ये वाला I2I, this is I1I current. That's what I told you. So this current, when you make it off, same current will go to the load. That's what we have drawn. This is V0. The same current will go to the load here now. That's what we have drawn. Look at here now. I0 में क्या है इधर? I0 में when this is on, chopper is on, you don't get any current. आपको current नहीं मिलेगा. Same thing I'm drawing. When this is off, what will happen? The current which you have drawn, whatever the current you have drawn here now, this current will come. IT2 or I2 and I1. That's what I'm saying. Now, to find the average output voltage, and we are equating the energies of the inductor. So, for example, energy input to the inductor. Inductor के बारे में बात कर रहे हैं. Energy input to L. What will happen? Energy input to L, VIT. This is Vs is the input to this one when it is on. Input voltage is Vs. IT, VIT is the energy. I is average current. Current क्या है? I1 से I2 पे जा रहे, ठीक है? I1 plus I2 by 2. This is basically VIT use कर रहा हूँ. Average current I1 plus I2 by 2. And T is turn on period. Energy input to the inductor. And during off period, this is on है ना? During on energy input कब होगा? During on period में. During turn off period में क्या होगा? ये तो बंद कर दिया. So then what will happen? Energy is releasing. I hope you understand that turn on, turn off. I have already drawn. This is turn on. Nothing else will come and turn off. ठीक है? Inductor. Now this is connected to load. This is off period में inductor इधर आएगा. During turn off period, what will happen? Inductor. Inductor का voltage कितना हो गया? VAT लेना चाहिए. Energy during off period. So what is this? I told you current is kind of इधर प्लस आ गया क्योंकि इसका एनर्जी रिलीज कर रहे हैं. सो प्लस हियर माइनस हियर, इधर VSI, ठीक है? तो ये वाला V0 है. What is VL here now? If you apply the KVL, VL equal to, in this case, V0 minus VS. V0 minus VS. Just apply the KVL. So now V0 minus VS, इंडक्टर के बारे में बात कर रहा हूं हमने. एनर्जी in the inductor during off period, and I1 plus I2 and during turn off period. So whatever the energy is taken in the inductor during on period, energy released by the inductor during off period both should be kind of equal here. It has to be balanced. So equation 1 and equation 2 दोनों balance करना है. So what will happen here now? ये दोनों को balance करो, I1 by I2 it get cancels out. Only you are remaining with Vs T on and V0 minus Vs. ये वाला important point है, energy taken by the inductor and energy released by the inductor has to be equal. Vs T on V0 minus Vs T off. So this becomes here now. हमको क्या चाहिए? V0 चाहिए ना? So simplifying this one, Vs ये वाला देखो, just expanding Vs T on. Here minus Vs T off आ गई, इस तरफ लेके आया. Vs T off होगा. Please look at the calculation. V0 T off. Is that fine? Vs को you take the Vs common. Total T and V0 T off. So V0 equal to T by T off. T by T off. V0 equal to T by T off. Let me do that simplification. V0 which is equal to Vs into T by T off. T off can be written as T by T minus T on. So final expression I am writing here now. Can I take a T common ले लो? अगर T common लिया तो 1 by 1 minus T on by T. T on by T is alpha. V0 which is equal to T by T common ले लो 1 minus T on by T. This becomes 1 by 1 minus alpha into Vs. Do you agree with me? So the final expression is 1 by 1 minus alpha Vs is the output voltage. Alpha 0.5 रखो. You can check it. Alpha is again this definition is same. Alpha का definition is T on period है. T on by T only. Duty cycle definition तो वही है. On by T. So 1 by 1 minus alpha. So alpha substitute करो, मान लो duty cycle आपने 0.5 रखो. 1 by 1 minus 0.5. So 2 times Vs. V0 क्या होगा? 2 times आएगा. ये क्यों आ रही है? Why the output voltage is more than the supply voltage? Why the output voltage is more than supply voltage? Because I have inductor. अगर इधर inductor नहीं तो क्या होगा? If the inductor is not there, the energy will not be there. Additional voltage will not be obtained with the load. Just because of this inductor, during on period where inductor energize हो रही, ठीक है? तो during off period, chopper off period, जो भी energy inductor में आया, that inductor is releasing the energy to this. Okay, do you understand what we have done? So please copy this, and this is a step up chopper. Now we'll move on to the what are the types of choppers. We have few varieties, type A and type B, type C chopper. So let us see that one. Step down and step up chopper also will come, but with a different circuit here now. So let me do that here. Types of chopper. First one is type A chopper. This is same as what we have done is step down chopper. Step down chopper. Or this can be called as first quadrant. First quadrant chopper. First quadrant means this operation is, we say voltage V0 and I0 here now. So this operation is only in the first quadrant, meaning V0 positive and I0 positive. V0 is positive always, I0 is positive always here now. In this chopper, we have already seen it. Let me show it to you here. Okay, this is RLE load as I mentioned. From now onwards, you can consider default in RLE loading. So Vs plus, and this is what the chopper. Yevala chopper, right? And this is FD. So we already seen, only look at the V0 and I0. We have already given the explanation to it. When this is on, when chopper is on, मैंने बता दिया already, so complete V0 equal to Vs. When chopper is off, what will happen? Let me write it one by one. During on, CH is on, FD is off, FD is off, V0 equal to Vs. During off, what is happening? Chopper is off, that's what it means, off period में V0, FD is on, FD on हो गया, तो V0 कितना होगा? 0 होगा, ये on हो गया, V0 0 होगा. That's all. Have you seen anywhere the current is going negative? Have you seen anywhere V0 is going negative or V0 average value is going negative? Nothing. So this is a type A chopper. So first one, which we've already discussed, is like waveforms drawn and here. Second one, देखलो, type B chopper, or I can say here now second quadrant. Second quadrant, they were first quadrant. Or this is step up chopper. So different variety of step up. Yes, definitely output voltage is more, but let us see here now. network which I have given previously is different from what I'm drawing here. But definitely inductor has to be there. This is I naught and plus Vs. This is some diode D. I did not get fueling diode क्योंकि chopper parallel में current कर दिया. So this itself is acting as FT. When it short circuited, current will be there to make the current continuous. So what is happening here now during on period? During on, V0 is definitely on period. V0 is 0. I agree. But what is happening here now? The load voltage E in a back EMF in case of DC motor. So the energy is stored. You can see the current. Current is going in this direction. So I0 is negative. Current इधर से आएगा. Current. So let me show here now if you have any doubt on this one. On period, I mean it won't matter because this is plus minus sign. So this one will not come into picture. So this is open and chopper is on and inductor. So E here now, and this is how, and this is how current is going. Current is going in this direction. So plus V0, V0 equal to short circuit होगा. Vs इधर है. So since it is short circuit, it won't conduct, it get open. So V0 is 0, but current in opposite direction. Now what is happening in the off period? Please understand carefully. During off period, on period mein, yes, V0 0, I0 negative. Okay. And energy, inductor L takes energy. Your inductor है ना? That inductor takes the energy. Energy ले रहा है इधर. Off, इस chopper को off कर दिया. See the beauty here. इसको off कर दिया मैंने. Then what will happen now? Inductor, it has released the energy. Inductor release करना मतलब what will happen here? मैंने already बता दिया. इसका polarities will get interchange. This I'm talking about. Previously plus इधर, minus इधर. अभी ये release करना है ना, तो अभी plus इधर, minus इधर आएगा. Plus of course minus ये वाला E है. So E इसका voltage कितना है? L di by dt. Some I1 to I2 or I2 to I1. E plus L di by dt. What is the total voltage here now? V0 में कितना voltage आया? V0 में E plus L di by dt. This voltage is more than the Vs. So anode side में voltage ये तो बंद कर दिया हमने, deliberately open कर दिया मैंने. तो इसका diode, what will happen to the diode here now? Diode चालू हो जाएगा इधर, क्योंकि right side voltage is more. So now this voltage is Vs here. This is diode, T is on. V0 is more than Vs. So definitely V0 is more than Vs here now in this case. And diode is on. Of course, chopper is off. Then this is the case. So don't you think the I0, again the I0 is going in this direction, or the current is kind of going in this direction. So इसलिए, but always V0 positive. Look at here V0. V0 direction is plus top line, minus नीचे. V0 positive in this case, I would say here now. V0 is in this case is positive. I0 is negative. This is happening in case of the turn off period. सो आपने quadrant के फॉर्म में ड्रॉ करो. If you draw in quadrant here now, I'm just trying to draw. Quadrant is V0 and I0. V0 is positive, इधर 0 है, ठीक है, छोड़ दो. दोनों on and off में current is negative. So means this is a second quadrant operand. I0 is negative, V0 is positive. This is where it's operating. Okay. Please copy this. Shall I move on to next one? Class type A, type B, type C chopper. Let me move on. Next one is type C chopper. This is two quadrant. Type C chopper, two quadrant. So actually it's a combination of 1 and 2, type 1 and type 2. Circuit kaise hoga? Let us see here now. Both together in one chopper. switches are choppers, but actually इसके अंदर क्या है बाद में देखना पड़ेगा. What is this consisting of? D and this of D. So average voltage or output voltage V naught here, L and E I naught here. So now how the operation is happening here, let us see. So what should happen? Two quadrant operation, you know, we are able to get, this is how V naught and I naught. Always we should get V naught positive, but current are two directions. Current is two directional, so current ये वाला डायरेक्शन में आना चाहिए, opposite में जाना चाहिए. Look at this one please. When CH1 is on, type A chopper देख लो, type A मतलब step down chopper. When CH1 is on, the current will go like this, positive, and your V0 is always, V0 is positive here now. So this is what I am writing. CH1 on, everything else off. So V0 is positive. This is how. I0 is also positive. जो भी direction हमने दिखाया, the same direction it is there. When CH2 is on, ये वाला ऑन हो गया तो क्या होगा देखो, current is coming in this direction. ये ऑन हो गया ना, so current is coming in this direction. So I naught opposite में गया, लेकिन V naught तो वही है, V naught because इसका voltage ज्यादा है, more voltage. So because plus here minus here होगा, plus minus, तो V naught is still positive. I naught is negative आ गया. Not only this here, same scenario will happen now. CH2 on, or another case क्या है, diode. Somehow if diode is also on, yes, there are scenarios where अगर मान लो CH2 को ऑफ पीरियड में कर दिया, ऑफ, CH1 ऑन नहीं है, तो क्या होगा, अभी एनर्जी है ना, so this is what, or diode on. In which case diode will get on? When both are kind of not on, CH2 is off, and this is what I'm saying, CH2 off हो गया, डायोड ऑन हो गया. डायोड हमने नहीं कर रहा ऑन, सर्क्यूट ने कर रहे हैं, मतलब ऑटोमेटिकली इधर प्लस आ जाएगा, माइनस प्लस माइनस, इसका वोल्टेज इज मोर, V naught is kind of more than Vs, so this one is V naught is more than Vs, and this is in fact is a step up chopper. ये वाला period, whatever I am discussing here now, this is step up chopper. So two scenarios है इधर, अगर आपने चॉपर 2 को ऑन कर दिया और D ऑन, चॉपर ऑफ, ओनली कंट्रोल क्या है हमको, चॉपर के ऊपर ही होगा, डायोड के ऊपर नहीं होगा. डायोड सर्क्यूट विल डिसाइड, डायोड सर्क्यूट विल डिसाइड. चॉपर ऑफ हो गया तो इस तरफ वाला वोल्टेज ज्यादा है, so then it is moving on. Step up chopper, this one is step down. So when, okay, let me show here, maybe first time this is, next time not necessary. Let me show here, ऑन कर दिया चॉपर को तो ये वाला, I'm just showing here now Vs, this is CH1, remaining all, whatever is there, wherever I have not shown, that is a open scenario. This is inductor E, V naught इधर है ना, डोंट यू थिंक V0 इक्वल टू BS स्टेप डाउन चॉपर के लिए? I0 क्या है? दोनों पॉजिटिव है ना? What will happen? दोनों when the chopper is off, CH1 is off, 1 ऑफ हो गया, तो क्या हो गया? If CH1 is off, FD will get on. Let us see it now. ये बंद कर दिया आपने क्योंकि इधर एनर्जी है इसमें, तो what will happen? It started releasing here now. So previously when it is charging up, इधर प्लस आ गया, माइनस आ गया. When this is getting charging up, when chopper is off, इसको बंद कर दिया तो क्या होगा? Only this inductor portion, inductor and this E, and ये तो chopper तो off है ऐसे भी, this is off. What will happen? Polarities are reversed, minus and plus. So इधर FD है ना, FD चालू हो गया. Then what will happen? V0 is 0 here now. V0 is 0, but what about the current? I want to take the current direction here now. Current direction क्या उसी direction में जाएगा? समझ गए ना बात? Please understand here now. This is how the current direction. When ये वाला बंद हो गया, ये वाला बंद हो गया, current continuous जाना चाहिए. So current continuous जाना चाहिए तो क्या होगा? FD on हो जाएगा. So when FD is on, the current is direction is like this. So current is positive only. So means overall conclusion क्या है? During on period, V0 positive, I0 positive. During CH1 off, V0 0, I0 positive. So look at here now. This is step down chopper. Whatever I have discussed, step down. Step up case में CH2 and diode will come into action. That's what I told you. When CH2 is on, and you can see the direction of the current. Current is in opposite direction. Let me show here. This is CH2, L and E. समझ में आ रहा है ना आपको? So how this is getting charging up? You can see here now. This is how it is getting charging up. So plus here, minus here, and you can see the direction of current. Representation is I0 here. लेकिन actual current opposite में जा रहे, तो I0 negative है. Now when CH2 is off, then ये वाला current है ना forcefully जाना चाहिए through diode. Then D is on, this is on. Then what will happen? Current starts going to this. This is on. So this is S and L here, E. Now the current starts going in this direction. मैंने बता दिया already. This is how the current going to this. But actually current direction is I0 here. And plus here it start releasing the energy to the source like this, and I0 direction. So this is CHD is off, then D is on, then I0 which is negative here now. So हमने जो भी डिस्कस कर दिया इधर, that is true. CH2 is on, V0 is this, and CHD is off, D on, V0 is greater than VS, and your I0 is negative. So this is step up chopper, this step down chopper, and your coordinate operation is here. Next one, we have type D chopper also. I'll just show here how the connection is there. In this case, your V0 is negative. So here it is. V naught is negative, like in current denotation. Let us see here now. Simple to explain this. Your load I plus minus whatever the representation I have given, that is a positive one. Anything else you get it, it's minus. Current is जो भी हमने discuss, जो भी representation दिया है वो positive है. बाकी वाला है ना opposite direction वाला negative. CH1, CH2. D1, D2. So let us see here now. In this case, V naught negative आना चाहिए, positive negative आना चाहिए, current positive आना चाहिए. Look at the operation. CH1 and CH2 are on. Both are on. Both choppers are on. What will happen? Let us see. Let me draw that. V naught is, this is V naught, which is equal to Vs. During this is on period. ये on हो गया ना? So let me CH1 and 2. So I'm drawing this. Chopper is on. Either load I, AB on I, and Vs. And this is V naught. V naught equal to Vs. Diodes are off anyway. Now what is happening here now? During this period, I naught, this is RL load है ना? By default मैंने बता दिया RL load है. Current is kind of getting charging up, but the current is kind of increasing. So this is current is increasing, keep on, something like this. Then during off period, तो क्या होगा? इसका RL लोड है, अभी क्या होगा? इसका वोल्टेज रिवर्स हो जाएगा टर्मिनल्स, क्योंकि L का पोटेंशियल पोलैरिटी है ना, रिवर्स होगा ताकि आपका प्लस इधर माइनस इधर आएगा. Look at here now what is happening. So now this diode will conduct. RL लोड है by default मैंने बता दिया आपको. And chopper gets off. हमने खुद ही deliberately off कर दिया. And the current direction is this, it is going, but polarities of this will get changed. This is plus, and Vs here. V naught is still positive. V naught is still positive here. I'm sorry, V naught is negative, but I naught is positive. I naught is still positive. So what will happen? V naught. V naught, I'm drawing. This is minus sign during off period. So again during on period becomes positive, because this is how it is going on. Of course, same voltage, same represented curve, magnitude the same, only polarity. Whatever width you have drawn, here also same thing. Please try to maintain that. And off period, what will happen? Energy started releasing, so the current is kind of decreasing here. Again increases, again decreases. That's what's happening right now. So type D chopper is V naught is positive, negative आएगा, current is always positive. इसका average ले लो. This is sometimes in gate examination they'll say that take the average value of I naught something, some 10 amps, 20 amps. So calculate करना है. ठीक है? So that way V naught positive, negative आएगा. I naught is always positive. You can see that. That's a type D chopper. Okay. There is something called type P chopper altogether. All quadrants. I'll give the network here now. No need to remember by heart. I'll give that also to you. Please copy this one. Shall we move on? Type P chopper, 4-quadrant chopper. Need not remember this. Need not remember any circuit, in fact, for that matter. Only operation. When something is given, you should know how this will get operated. Okay, these are choppers means switches only. And where is your load? My load kahan hai? Load is here now. And positive directions are V naught and I naught here. That's all. All 4 quadrants, whatever we have discussed, type A, B, C, D, will be there in type B. So its operation is V naught, I naught. All quadrants get operated. Whatever the one you need to operate, all 4 will be operated. So I'll explain here now. I'll write it here. What is happening? So this is CH1 and CH4, 1 and 4 on, 1 and 4 on हुआ तो करंट इसमें जाएगा, स्टेप डाउन चॉपर है, and CH1 of second case में this will off, then 4 and D2 this will operate. CH1 is off, CH4 and D2 conduct. This is the operation, and this is step down. We already discussed first quadrant one, and this is second quadrant, step up by इसके लिए CH2 D4, then L stores energy, CH2 D4 on कर दिया तो CH2 and D4, CH2 on कर दो तो इसकी energy, this is how. When CH2 is off, ये बंद कर दिया तो पहले D4 है ना, now D4 the current has to, this we know, current has to in opposite direction, so the current has to go this way. CH2 off, D1 D4, D1 D4 conducts. Similarly here now, CH3 CH2 on, 3 and 2 on, so CH3 off, then CH2 and T4 conduct. Here CH4 T2, L stores energy of, no need to remember, just you need to understand how this get functions, which we already discussed. D2 D3 conduct, of course E reversed, regenerative braking हुआ तो E reverse करना है, here also E reverse. Basically ये वाला step down है, ये step up है, अब this also step down, and this is also step up, दोनों step up है, दोनों step down है. This is how operates. हमारा मर्जी से कौन सा क्वाड्रेंट ऑपरेशन करना है, ये करना, ये करना, ये करना, नहीं तो दो करना है. So we can do that one, 4 quadrant operation. So let us copy that one. So whatever we have discussed in today's one is important thing is Fourier analysis and step down chopper average value, RMS value. Okay. And nothing, and another one is inductor energy stored. Inductor energy stored and energy release equation equal कर दिया ना, that is important. These are the 3 things important. And बाकी चीजें याद रखने की जरूरत नहीं, but लेकिन ये वाला याद रखना है, Fourier series वाला याद रखना है. So average value, RMS voltage and average voltage याद रखना चाहिए, ठीक है. And the energy equations of inductor, that is keep on I'll be using in another circuit also. So you have to remember these things, how doing here now. Other things type A, type B, type C, type E, याद रखने की जरूरत नहीं, but when the circuit is given, you should be in a position to explain what is happening, right? Yeah, if you have any doubts, you can ask me. Otherwise, I'll stop for the day. Tomorrow we can continue anyway. Right. Okay, Sahu, cool. Good. Okay then. Thank you guys. And evening we'll meet for machines then. We'll start mostly induction motor. Otherwise, let us see more questions. Okay then. Bye guys then. Okay, thank you guys. Thank you, Sahu. I'll wind up the session then. Thank you, Bhaskar, Sangyotika, Sujita. Yeah.